Yesterday we started dipping our toes into the complex number system. If you recall, I is equal to the square root of -1, and we used that when we were simplifying radicals that had negative numbers in them. And then today we're going to get into I squared. I squared is going to equal -1. You can never have a final answer with I squared in it because any I squared can be replaced with the number -1. All right, we're going to start real basic. Adding and subtracting, you can add regular numbers with regular numbers, i's with i's. It's kind of like they were just x's. Same thing. So if we're doing 4 minus I plus 3 plus 2i, some people like stacking them vertically. So 4 plus I could put the plus 3 underneath the 4. I could put the plus 2i under the I. And then 4 plus 3 is 7. -1i plus 2i is 1i. Now remember, when you're using i's, they have to hang off at the end. The imaginary numbers hang off at the end. So you wouldn't write I plus 7. You make it 7 plus I. Something to be careful for with subtraction, though. Here's what I recommend. This avoids having to worry about like minus -6i is really plus positive. I can't write plus signs. What I do right away on something like b is when I have minus, I just change everything in the parentheses after it to its opposite. So I make it -1 and I make it positive 5i because it would be minus -5i. So I just make it plus 5i and then that's handled. So 7 minus 1 is 6, -5i plus 5i cancels. So that one just comes out to 6. All right, so here, let's go ahead and just change all the signs first. I'm not going to stack this one because I have 3 groups, but we'll figure it out. So we'll make it 6 plus 2 minus 9i. And then here, if you're doing plus, you don't have to change anything. So plus -8, I'll just make -8, and then plus 4i. So if we get all our normal integers, we have 6 plus 2 is 8, minus 8 is 0. So those are all gone. So we just have -9i plus 4i, which is -5i. So I have 3 problems, very similar, that I'd like you to try out. So go ahead and pause it, check back in when you're done, and see how you did. All right. Plus 7 plus I, 9 plus 4i. Plus 10 minus 4i, 12 minus 10i. All right, -I plus 8 minus 2i minus 5 plus 9i. So our integers, we have 8 minus 5 is 3, -1, -2, positive 9 would be 6i. So hopefully you did well with those. I think next up we're going to get into some multiplying, baby. Oh, yeah. All right, here we go. 5i times -2. You've distributed a million times in your life. 5i times -2 is -10i. But 5i times I is going to be 5i squared. And this is what I was talking about. You're never going to have I squared in the final answer because every time you see I squared, you're going to substitute in a -1 in its place. So really, this becomes -10i. And then 5 times -1 makes it -5. And that's a great answer. But we can make it perfecter. Because remember, the imaginary number system should fall at the end. So I'm going to reorder this, make it -5 minus 10i. That is proper form. Now we're also professional FOILers. First, outer, inner, last. Which really all we're doing is making sure we multiply everything in one parentheses by everything in the other. So if I multiply the 7 first, 7 times -1 is -7. 7 times 2i is 14i. -4i times -1 is positive 4i. And -4i times positive 2i is -8i squared. Now again, we're going to substitute in -1 for that I squared. So it becomes -8 times -1, which is going to change it to positive 8 back there. So let's see what we got. We got -7. We can combine 14i plus 4i is 18i. And then it turned into plus 8 at the back. And we can still combine our integers here. Negative 7 plus 8 is 1 plus 18i. That's all we can do. Oh, if you look at 3, that's a difference of squares. You could FOIL it out, but there's a shortcut there. When you have a difference of squares, you square the first term. 6 times 6 is 36. You put a minus, and you square the last term. 3i times 3i is 9i squared. We don't leave I squared. We trade that out for negative 1. So this becomes negative 9 times negative 1, which is positive 9. 36 plus 9 is 45. Look at that. We had i's all over the place, and somehow it just turned into one integer. That's crazy. That's wild. So I'd like you to try out these 3. Again, pause it, check back in when you're done, see how you do. Plus 5i plus 8i plus I squared. I squared is negative 1, 40. 5i and 8i is 13i. Then we can do the 40 minus 1, 39 plus 13i. Square the first term, 49, make it a minus. Square the second term, 25i squared. Negative 25 times negative 1 makes it positive 25, which gives us 74. Woo! Fun! Fun! Complex conjugates. Couldn't be easier. All you have to do is change the plus and minus. So the complex conjugate to 2i minus 15 is 2i plus 15. Negative 4i would be positive 4i. 9 minus i is 9 plus I. And I plus root 3 is I minus root 3. You literally just changed the plus and minus. We're going to do this when we have imaginary numbers in our denominator. Kind of like you can't have radicals in your denominator, you can't have imaginary numbers in your denominator either. So we're going to have to do what we did when we rationalized denominators earlier. So here's what we do. Look at the denominator, 1 minus 2i. That's a problem. The way we're going to fix that problem is we're going to multiply by the complex conjugate, which would make it 1 plus 2i. Because when we do that, that's going to create a difference of squares, and the i's will cancel out in the long run. But remember, if you do that to the denominator, you also have to multiply the numerator by that. So we got a FOIL up top. 5 times 1 is 5. 5 times 2i is 10i. 3i times 1 is 3i. And 3i times 2i is 6i squared. How about this? Here's how rebellious I'm feeling. 6i squared, I'm going to make it 6 times negative 1 because I squared equals negative 1. Denominator, difference of squares. So you square the first term. 1 times 1 is 1. You put a minus, and you square the second term. 2i times 2i is 4i squared. But again, I'm going to replace the I squared with a negative 1. So this becomes 1. Look, negative 4 times negative 1 is positive 4. So our denominator just became 5. How fun. We still got some work to do in the numerator. Look, I have 6 times negative 1. That's negative 6. So we could do 5 plus negative 6, which is negative 1. And then the i's, I have 10i plus 3i. That's 13i. The only other thing, so that's it, and that's fine. The only other thing you might want to check is if you can simplify any part of the fraction. So let's say we had something like negative 8 plus 6i over 4. Now you could divide all those by 2 if you'd like, or what you can do is you can split that into 2 fractions and simplify them separately. So this is the same. So if we divided them all by 2, like a common factor of 2, that would make it negative 4 plus 3i over 2. And that's cool. I'll take that answer. I love it. Another thing you can do is split it into 2 fractions. Negative 8 over 4 plus 6i over 4. And you can simplify each of those, and it'll look a little different than what we got here. So negative 8 over 4 is just negative 2. And then you have this 6i over 4. That would be 3i over 2 if you simplified it. So you would have two different options if you can simplify. But think of this green answer we initially got. If you split that, it'd be negative 1 over 5, which you can't simplify anymore. And it'd be 13i over 5, which you can't simplify that either. So there's no point in splitting that one. All right. We got two more and then one for you to try. Now here, the complex conjugate would be negative 4i. But let me just tell you this. Since it's just a monomial, all we need it to be is something I squared. So I don't even need the negative 4. I can just multiply it by negative I. And before I even do that in the numerator, watch what happens. 4i times negative 4i would be negative 4i squared. I squared is equal to negative 1, so it would be negative 4 times negative 1, which is positive 4. Now, you could do negative 4i, and it'll still work out the same. There's just going to be some steps later where you're going to have to take out some common factors, and it'll work. But we just saved ourselves a bit of work. We got rid of the I in the denominator, which is the whole thing we need to do. So I still need to multiply negative I up in the numerator. I keep changing colors. So negative 5 times negative I is positive 5i. Negative 3i times negative I is positive 3i squared. And I'm going to make I squared negative 1. So this becomes 5i. 3 times negative 1 is negative 3. And that's a great, great answer. But remember, the imaginary numbers should be at the back. So a better answer would be negative 3 plus 5i over 4. Now, if you split that, you'd have negative 3 over 4. You can't simplify that. You'd have 5i over 4. You can't simplify that either. So there's no point in splitting it when you can't do anything. So just leave it together. One more of those. Ooh! Wow! Look at the denominator, 6 plus I root 2. So we're going to multiply by the complex conjugate, 6 minus I root 2. We're going to have to do that in the numerator too. So if we FOIL the numerator, we have 6 times 6. That's 36. We have positive 6 times negative I root 2. We could do the 6 times the I. So that would be negative 6i root 2. All right, here we have negative I root 2 times 6. That's going to give us another negative 6i root 2. I need a longer line here. And then we have negative I root 2 times negative I root 2. Negative times negative is positive. On the outside, we'll have I squared. Inside, 2 times 2 is 4. Now, we got a lot to clean up there, but we'll come back to it. I'm going to trip over a chair instead real quick. All right, denominator, difference of squares. We square the first term, 36. We put minus, we square the last term. I root 2 times I root 2 would be I squared root 4. Again, this has some stuff to clean up here. So let's get this I squared root 4. I squared is negative 1, square root of 4 is 2. This becomes negative 2. So it would say 36 minus negative 2, which is really 36 plus 2, which is 38. So our denominator is going to be 38. That was tough. All right. Now here, I squared is negative 1. Square root of 4 is 2. So this becomes negative 1 times 2, which is just negative 2. So let's see what we can do in the numerator here. I have 36 minus 2. That's 34. And then I have negative 6i root 2 and negative 6i root 2. That'd give me negative 12i root 2. All of these are divisible by 2. Now let's pretend like we didn't know all of them were divisible by 2. Maybe some of them are divisible by 4. I don't know. But let's just split this into two fractions. 34 38ths and then minus 12I root 2 over 38. So if I simplified them separately, 34 over 38 would be 17/19. Minus, I could do the 12 and 38, divide them both by 2, 6I root 2 over 19. Once I noticed that they ended up with the same denominator, I could mush them back together. 17 minus 6I root 2 over 19. Cool. Or you could have divided them all by 2 right here. 34 divided by 2 is 17, 12 divided by 2 is 6, and 38 divided by 2 is 19. But again, like you saw in the earlier example, maybe one of the fractions simplifies different than the second fraction, and that's okay too. So I have one for you to try. Give it a pause, give it a try, see how you do. Minus -1. There it is. We had some fun. We shared some laughs for everyone.